Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called Hook, Line, and Sinker by PageDo, and here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit such that every row, column, and designated 9-cell region contains the digits 1 through 9 exactly once each. For accessibility, most of the lines have been marked with an abbreviation to distinguish them as an alternative to the line's colors. Cells connected by a pink red band line form a set of consecutive digits in any order without repeats. So, for example, we could have something like, say, 4, 6, 5, 3, and 2 here, and that would be valid because this forms a set of consecutive digits, 2, 3, 4, 5, 6. What we could not have, though, is something like 8, 3, 4, 5, 6, or 8, 3, 4, 6, 5, whatever you want, however you want to designate that, because it does not form a set of consecutive digits in any order without repeats. There's a gap between the 6 and the 8. So that's an example of how red band lines work. We have adjacent digits along a green German whisper line must differ by at least 5. And I'm going to be calling this a whisper 5 line because a setter came up with that name, and I thought it made a lot more sense because it's more easily extensible. So as an example, say this was a 3 here, then this digit would have to be 8 or 9, because the only digits which are 5 or more away from 3 are 8 and 9. So this is the hook here. The red band is the hook. The sinker is the whisper 5 line, and I'm not sure what the line. Usually the line refers to the part that's extended, right? This is the rod, which we don't explain. And I guess we have fishes here. So the region sum lines are the fishes here. Anyways, one on a tangent. So that's an example of how a whisper 5 line / German whisper line works. We have box borders divide a blue region sum line into segments with the same sum, and those are all the fishes with these eyes here. And so what does it mean to be box borders divides? So box borders divide the line into segments. So this is a segment and this is a segment with the same sum, which means these two digits must sum up to the same digit or the same sum as this segment. So we could have 2 and 4 here, and then this would be 6, because these two digits must sum up to the same sum as this segment here, which is a single digit here. So that's an example of how region sum lines work. We have adjacent digits along a red parity line. One digit is odd, the other digit is even. So for every adjacent pair on the red parity line, one is odd and one is even. So for example, if this were, say, a 6, this would have to be a 1, 3, 5, 7, or 9 to be odd to be next to it. And that's an example of how parity lines work. It's a palindrome. I didn't see a... So the line is the palindrome. The rod is the parity line, and the gray palindrome line is the line itself. So digits on a double gray palindrome line read the same forwards and backwards. So, for example, we could have something like 7, 5, 3, 5, 7, and that reads the same way for one direction as it does the other direction. So that's an example of how parity lines work. Gray circles only contain odd digits, so this must be odd. digits in circles joined by an X sum to 10, and digits in cells joined by a V sum to 5. So for example, if this were 6 here, this would have to be 4 here, and this would have to be 1 here, because these two digits must add up to 10 because they have an X between them, and these two digits must add up to a 5, or 5 because there's a V between them. So that's how X's and V's work. Digits in cells joined by a white dot are consecutive. So, for example, if we had a 4 here, this would have to be 3 or 5 to be consecutive with it. Because those are the only digits consecutive with a 4, and they have to be consecutive because there's a white dot in between. And not all X's, V's, or dots are necessarily given, which means there is no negative constraint. And don't worry about that, what that means, because I should explain it in another puzzle. I'll explain it some other time. Well, I explain it in puzzles where there is a negative constraint, but those are very rarely very easy puzzles. Maybe I should explain it here. A negative constraint means that if it said, for example, all X's, V's, and dots are given, that would be a negative constraint, because that constrains the puzzle in the negative way. Because since we know all X's, V's, and dots must be given, that means if there is no X, V, or dot between them, we know they cannot add up to 10, we know they can't add up to 5, and we know they can't be consecutive. That's just what the negative constraint means. But we don't have that in this puzzle. I guess I never really explain it, because if you usually have a negative constraint, it requires a lot more logic to figure that out and to figure out where to use that. Whereas if you just have the positive constraints there, it's usually pretty obvious where to target that. So usually it's going to be a harder puzzle. Anyways, that's the explanation of what a negative constraint is. But we don't have that in this puzzle, so keep that in mind. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's learn how to Sudoku. Okay, where do we want to start? Let's start with column 8. And in column 8, we have 4 cells which must add up to 5. That means those digits must be 1 through 4. Well, that forms a 1, 2, 3, 4 quadruplet in column 8, which eliminates 1 through 4 in the rest of the column. So that means the remaining digits in that column have to be 5 through 9. And this adds up 10 specifically with this digit, so this cannot be 5. These are consecutive. And that's really all we have for that. These must be adding up to 5, so it's 1 through 4. These must add up to 5, 1 through 4. So I guess we'll go through all the V's. Here. Can 5 ever be on an end? The answer... So these are all consecutive. So that means it must be essentially like a Ren band, if you think about it, but in a specific order. So if we had 5 at the end of one of these, it would have to be 1, 2, 3, 4, 5, or 5, 6, 7, 8, 9. But the problem is here we have 2 digits adding up to 10, which guarantees we have to have 1 digit that's low and 1 digit that's high. The low digits being 1 through 4 and the high digits being 6 through 9. So actually, let's mark these as blue and red. And then we'll mark pink for a possible 5-digit. Well, this is a blue-red pair here. And so you cannot have 5 ever be at one of the ends. Because if it were at one of the ends, then it wouldn't... Well, first of all, actually, you can't have 5 through 9 at all here, because that would eliminate all possibilities for that cell there. But the same thing, if you can't have 1 through 5 here, because that would eliminate all possibilities for the low digit that's here to add up to 10. So 5 cannot be at the end. 5 has to be one of these 3 digits, which means you're guaranteed to have 4 or 6 on this stretch, this pseudo Renban line thing, where it has to be in order. Right? Because 5 has to be in the middle. It has to be between a 4 and a 6. So one of these 5 is definitely going to have a 4 and a 6 surrounding it. So that eliminates 4 and 6 in the rest of the column. So this can't be 4 or 6. So that can't be 4. This can't be 1 then to add up to 5. And this has to be 1, 2, 3 with 7, 8, and 9 to add up to 10 there. Okay. That means this can't be 3 and 7 either. If this is 3 and 7, how do you form a 5-length Renban with that? You can't. So this has to be 1 or 9 or 2 and 8 here. So these digits, again, you cannot have 1 or 9 on them. But they can be 2 through 8 here. But no 5 on the ends. This digit has to be the opposite parity as both of these. Okay, so then... Okay, so let's mark that as... remove the highs. These have to be the same parity. Right? It's either 1, 9, or they're both 2, 8. So the question is, this alternates parities. We have 5 odd digits and 4 even digits. But on this parity, we're going to have 4 that are the same parity here and 3 that are the same parity here. So if those are both even, we're going to have at least 5 even digits in the row, which is not possible. So this cannot be even, which means these must both be odd, which means this is a 1-9 pair. That eliminates 1-4 in the rest of the box, and it also eliminates 1-9 in the rest of the row. So we now have 4 evens left and 3 odds in row 2. So the outer digits must be even, or even. Let's make that orange. And the inner digits must be odd, which we'll mark as yellow. So this must be odd, which means this has to be 7 and 3, adding up together. 3 and 2 add up to 5. Therefore, this can't be 2 or 3. It's 1, 4 as a pair. We now have no 7 in column 8. This has to be even. So no 3 or 7. We don't have 7 available. So to form a Renban, it has to be 2 through 6, which forces this to be an 8 here. No 3 here, so no 2 there. So this must be 2 through 6, which means 5 cannot be in the middle. This is then 4 in the middle. We have 2 or 6 here. This is 2 or 6 there. This has to be a 3-5 pair here. And that forms that rip. This can't be 2 because of a 2-3 pair in the box. So this is 6, which makes this 5, which makes that 3, and that 2. This cannot be 2 and 3 as a pair to add up to 5 because we have a 2 in the column. 8 eliminates 8 here. These 3 digits add up to a single digit here, and it must add up to the same single digit here. So this cannot be, it has to be either 1, 3, 4 adding up to 8, or 1, 3, 5 adding up to 9. So this is 8 or 9. These digits are consecutive, so therefore they have to have a difference of 1 between them. And these must sum up to that digit, so therefore the 1 has to be there. So then this must be 7 or 8. 1 eliminates 1 here, so that's 4. 4, 2, and 3 at minimum add up to 9 at maximum there. So this must be, this can't be 4, it's 1. This has to be 4, 2, and 3, adding up to 9, which forces that to be 8. Which forces this to be 1, 3, and 5. That eliminates 5 in the rest of the box. So this becomes 6 or 9. So we have 1, 8 adding up to 4, 2, 3, and 1, 3, 5. Where is the 5 remaining in row 1? Cannot be here because the 5's in the boxes, so 5 has to be there. This is 6. Remaining digits of this box, this upper left-hand box, are 4, 7, and 8. Remaining digits of row 3, then, have to be 2 and 6. Remaining digits of this upper central box have to be 1, 7, and 8. And this lower upper right-hand box must be 4, 6, and 9. No 4 here because of 4 in the column, so 4 has to be here. Remaining digits of row 5, we have 5, 6, 7, and 9. This can't be 5 or 6 because of 5 or 6 in the column. And this must be consecutive. So no 9 there. So this has to be 6 consecutive with 5 or 7. So we're guaranteed one of these is 6. That eliminates 6 in the rest of the row. 5 eliminates 5 here. This is a 7, 9 pair, which eliminates 7, 9 in the rest of row 4. So this can't be 7. It's 5, 6 is a pair. These two digits must sum up to what that digit is, and therefore this can't be 4. This is a 6, which forces that to be a 6 on the palindrome. This must be 4, 7, 8 to match that, but it cannot be 8 because of 8 in the box. So that must match that, and this has to be 4, 7. Okay, on a Whisper 5 line, you'll always alternate between low digits and high digits. Because, and the low digits being 1 through 4, the high digits being 6 through 9. How do you know that? Well, what digits can be next to a low digit? Well, 1 can be next to 6 through 9, 2 can be next to 7 through 9, 3 can be next to 8 or 9, 4 can only be next to 9, which are all high digits. So next to a low digit must be a high digit. And the same thing, what digits can be next to a high digit? Well, 6 can be next to 1, 7 can be next to 1 or 2, 8 can be next to 1 through 3, and 9 can be next to 1 through 4, all of which are low digits. So we know since this is a high digit here, this must be a low digit here, which makes this high, this low, this high, and this low. They alternate between low and high digits. Well, we have 3 high digits, and 6 is also a high digit. This is a 5, and these are all lows. This is a high digit here. This is a high digit. So we have 4 high digits already in column 3, so the last digit remaining must be a low digit, which is only 4 available. Therefore, this must be 4 also. These two digits have to be at least 5 apart from each other, so we cannot have 3 and 7 here. So this is either 1, 9 or 2, 8 here, and this is the high digit, so this is, and this has to be an odd digit here on the gray circle, so it can only be 1 here, with that being 9. That means this can't be 9, it's 7. 7 can only be 5 or more away from 1 or 2, and this can't be 1 because of 1 in the column. So this is 2, which means this can't be a 2, 3 pair. It's 1 and 4 adding up to 5. That leaves this as an 8 here to be the last high digit, and 3 there to be the last low. Okay, remaining digits here are 3 and 9, and 9 can never add up with another digit to add up to a single digit, so this must be 3. And we have to have 3 and 5 adding up to 8 here. So this must be 3, 5 adding up to 8. That leaves that as 6. 7 eliminates 7 here, so it's 9. 6 eliminates 6 here, so it's 2 and 6. We have a remaining 9 in this left central box. 3 eliminates 3 here, so it's 2 and 3. 9 eliminates 9 here, so that's 1 and 9. This is not a high digit, this is low. 8 eliminates 8 here, so it's 7. 1 eliminates 1 here, so it's 4 and 1. 1 eliminates 1 here. 8 eliminates 8 here. These cannot add up to... Sorry, these add up to 10, but they have to form a Renban with each other. That's 5 in length. 2, 8 doesn't work. 1, 9 doesn't work. We already have a 6 on the line. So this cannot be 4, 6, so this must be 3, 7 as a pair. 1 eliminates 1 here, so this is 4 and 1. The rest of this Renban has to be 4 and 5. 3 eliminates 3 here, so it's 7 and 3. 4 eliminates 4 here, so it's 5 and 4. That means this cannot be 5. It cannot be pink. No more 9 here either because of 9 in the row. No 8 here because of 8 in the row. No 6 here because of 6 in the row. So if this is consecutive, this can't be 5. It has to be 6 with 5 there or 8 with 9 there. So this is high as the digit. Where is the 5 possible then in column 8? It has to be here. So this is 5 and 6 then, which means this can't be 6, that's 9, which makes that 6. And this can't be 6 or 9, so that's 8. So these 3 digits must sum up to what these 2 digits sum up to. These digits can be either 2, 8 or 4, 6. We're not sure which. But this can't be 2 or 8 because of 2 or 8 pair in the column. So 4 and 6 only adds up with 4 and 6. And it can't be 6 because of 6 in the column, so that's 4, which makes that a 6. Where is 8 in row 8? Cannot be here because of 8 in the box, so 8 has to be there. That eliminates 8 there. Where is 8 in row 1? It can only be here. Okay. Where is 1 in row 5? Can't be here because of 1's in the boxes. Can't be here because of 1 in the column, so 1 has to be there. Where is 1 in row 7? Can't be here because of 1's in the boxes, so it has to be there, which means this can't be 1. That's 7, which makes that 1. Let's go through the rows and columns which have 7 cells already fixed. Remaining digits in row 8 have to be 2 and 5. This can't be 2 because of 2 in the column, so this is 5, which makes that 2. Column 1 has just 5 and 7 remaining. This can't be 5 because of 5 in the row, so that's 7, which makes that 5. Column 2 has 2 and 8 remaining. This can't be 8 because of 8 in the row, so this is 2, which makes that 8. Now we have row 7 has 7 filled out, so we have to have 6 and 9 remaining. This can't be 6 because of 6 in the column, so that's 9 and 6 there. So these add up to 14 here, so this must add up to 14, which is 1, 6, and 7 there. Remaining digits in column 4. We have 2 and 3 remaining. This can't be 3 because of 3 in the box, so that's 2 and 3. Remaining digits of column 5. We have 7 and 9 remaining. This can't be 9 because of 9 in the box, so this is 7, which makes that 9. In this lower central box, the remaining digit is a 6. In column 6, the remaining digits are 2 and 5. And this can't be 2 because of 2 in the row, so that's 5 and 2 there. Which leaves this remaining digit as an 8, this remaining digit as a 9. That leaves that remaining digit as a 7, and this remaining digit as a 3. And that's how you solve it. Yeah, fairly straightforward. Not sure if there's any really tricky spots. I guess this is the only real one that's which is kind of the break-in, so it kind of simplifies things, I guess, a lot. Yeah, it's pretty straightforward. There's nothing that groundbreaking here. But I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.